All right, we're going to be talking about section 1.9 inverse relations. And so a couple things to take some notes on, to jot these down. Inverse is the reflection over the line y equal x. That's the simplest linear function. So that's a slope of 1/1 and a y-intercept of 0. And we'll see that in a little bit. If the coordinate point xy is on the graph, then the coordinate point yx is on the inverse graph. So you're kind of switching your x and the y because y equals x and x equals y. And the inverse of f of x looks like this. So this is not a -1 exponent. That just stands for f inverse. So that's how we would say that notation. So f inverse. So I want a little example here that we can kind of talk about. We're going to graph what f of x looks like. And then after we graph f of x, we'll graph its inverse. And we'll kind of talk about that. So first, I'm going to plug in some different values here. So if I plug in -2 here, so if I take -2 squared, that's 4. 4 minus 1 gives me 3. So the coordinate point -2, 3 is on that line. So if I plot that point -2, 3, and then if I plug in -1, -1 squared is 1, 1 minus 1 is 0. So that's going to be negative, right there, -1, 0. If I plug in 0, 0 squared is 0, 0 minus 1 is a -1. So it gives me 0, -1. And then plug in 1. 1 squared is 1. 1 minus 1 is 0. So I'll plot that point 1, 0. And then lastly, 2 squared, that's 4. 4 minus 1 is 3. So you can see that symmetry there. So this thing kind of looks like we'd expect a parabola U-shaped curve that looks like this. Now, the inverse, so that would be this. The inverse would be flip-flopping. So f inverse is going to be taking these coordinate points and flipping it. So if I had -2, 3, this one's going to be 3, -2. And if I had -1, 0, it'd be 0, -1. And then this one would be -1, 0. This one would be 0, +1, and then 3, 2. So I'll use a different color here just to denote that. So this one we had 3, -2. So 3, -2, I'll put that down there. And then we had 0, -1, put that there. -1, 0. 0, 1. And then 3, 2. And this function looks like that. That's its inverse. Now the line y equal x looks like this. So that's having a y-intercept of 0 and increasing that. So it's kind of reflecting along that line. That's what the inverse is, like we talked about in the notes before. Okay, so how do we actually find an inverse? We have a few different steps. First off, if it's in function notation, you're going to set it equal to y, replace it with y. So if you see f of x changes to y, if you see g of x changes to y, if you see h of x changes to y. If it's already equal to y, then you just leave it alone. Next, you're going to interchange x and y, which just means you're going to switch places. So wherever you see an x, you'll replace it with a y. Wherever you see a y, you'll replace it with an x. Whatever numbers you have, coefficients, exponents, those are going to stay identical. So you're only switching the x and the y. And then your third step is you're going to solve for the new y. So you'll use your steps necessary to do that one. So here's one example. So first off, first thing I'm going to do, kind of do it up here, is I'm going to set f of x equal to y. Now again, if it already has a y there, then you'll just move on. Skip that step. Then I switch x my y. So here's my y. I'm going to change it to x. And then over here, I see my x. I'm going to change it to y. Notice that the coefficient of 4 and that -6 did not change. You only switched, step 2, you're only switching x and y. And then we're just going to go ahead and solve for the new y. So I'm going to get rid of the 6, add it. So that gives me x plus 6 equals 4y. Divide both sides by 4, and that gives me x plus 6 over 4. And that would equal y, or we can now say that that would be f inverse. So f inverse equals x plus 6 over 4. Oops. Gives me that. So those are the rules that we're going to use, steps to do all these ones, even as they get more difficult. All right, same thing. Find the inverse of g of x equals the square root of x minus 4. So first step, change it to y. Second step, switch x and the y. So there's a y. I'm going to change it to x. Square root will stay the same. Minus 4 will stay the same. That x will change to y. And then last step, we're going to go ahead and solve it. So the first thing I need to do to solve it is I'm going to square both sides. And so x squared is just x squared. When I square a square root, those things cancel and just leave me a y minus 4. Now, if you did the opposite and square root of both sides, you'd have a plus or minus that we've talked about before. But just a reminder here, I don't need to do that. And then I need to get y by itself. So I'm going to add 4. And then that'll give me x squared plus 4 equals y. Or we could call that g inverse. And that equals x squared plus 4. That's its inverse. Okay, these are going to be a little bit more difficult with these rational functions when you have some variables all over the place, but we're still going to use the same strategy. So step 1, set it equal to y, what it already is. I don't have to worry about that one. Step 2, interchange the x and the y. So I change that y so it's x, and then 3 over here, and then that x down here will change to this. So now I have to go ahead and solve it. Now the only way, you could either cross multiply as one option, right, as x over 1, or what I like to do sometimes is this whole right side is being divided by the quantity y minus 4. So the opposite of dividing by a y minus 4 is to multiply. So I can multiply this by y minus 4 and this by y minus 4. Sorry, that was. And these cancel. So that would leave me with a y minus 4 times x, and then over here that equals 3. Now again, your ultimate goal is to get y by itself. There's only one y right here, and that's going to be really important as we see the next problem that's a little bit more difficult. So there's only one y to solve for. That makes this a little bit easier. So what I need to do is I need to get rid of this x right here. Well, this x is being multiplied over here towards this. So to get rid of a timesing by x, I'm going to divide. So then that will leave me with y minus 4 equals 3 over x. And I only have one more step to get this y by itself. I have to get rid of this minus 4. So plus 4 plus 4. So then that'll give me y equals 3 over x plus 4. Or you could also call it y inverse. And then 3 over x plus 4. So your goal here was to get rid of all the denominators and then basically just solve for that y. But this is going to be a little bit different on the next problem. Here we only had one y to solve for, so we just got rid and divided by that x first. The next example is going to be a little bit different. So this time you'll see that there's a couple of x's. So same thing. First step, have y equals. We already do. Second step, interchange those x's and the y. So that'll give me x equals, I'm going to have y plus 1 because I'm replacing and switching that x with the y. Same thing down here, it would be y minus 2. Now, in order to get rid of this denominator again, the opposite of a y minus 2 in times area in dividing is to go ahead and times. That would cancel that. Over here, y minus 2. So then I have y minus 2 times x equals y plus 1. Notice the last example, there was only one y. This time I have 2. So this is a completely different strategy. It's a little confusing. So what I have to do is I'm actually going to get rid of these parentheses. I'm going to distribute this x to here and here. Well, x times y is an xy, and x times a negative 2 is a negative 2x. The idea behind this strategy is if you've got more than one y, you need to get the y's on one side. So that's what I'm going to do. If any term has a y, I'm going to get it on the left-hand side. If it does not have a y, I'm going to get it to the right-hand side. So xy. This has a y, I want on the left-hand side, so I'll keep it there. Negative 2x. This does not have a y, which means I'm going to get rid of it. So I'm going to do the opposite, which is to plus 2x. So I plus 2x to both sides. Over on this side, I have a y. I want anything with a y on the other side, so I'm going to subtract it. So I'm going to minus y here. I'm going to minus y here. And then lastly, this is a plus 1. I'm going to leave it there. So what I end up having is I've got x, y, minus y equals. So this was gone. Here's my xy. Here's my minus y. Over here, this is gone. And I have a 1 plus a 2x or a 2x plus 1. Now, the whole idea behind this is now that you have a y where that's common, we can take a GCF. So I'm going to GCF out a y. So remember, when we factor this at the beginning of the year, if I take an xy and divide it by y, that leaves me an x. And then here, if I take a negative y and divide it by a y, well, y divided by y is just a 1. And so I get 2x plus 1 over here. That didn't change. So if you want to double check, y times x is xy, y times a negative 1 is a negative 1y, or just a negative y. And then you're almost actually done here, because our goal is to get that y by itself. That's being multiplied by an x minus 1. So the opposite is to divide it. So I just divide this by the same thing, and I end up getting my y inverse is 2x plus 1 over x minus 1. And that is my final answer.